So we're talking about long division, and long division is where you have something like this, which is 462 divided by 12. We can actually do that with polynomials. It does not sound like fun, and we're not actually going to do it with polynomials, but we do need to discuss some vocabulary because you need to know what some of these pieces are. When you have a polynomial, let's begin down here with our vocabulary. This part up here is called the quotient. And this part is called the dividend. This out here is called the divisor. And this down here is called the remainder. When you divide polynomials, what you're doing is you are figuring out what the factors are. So if you were to multiply x plus 1 and x plus 2, you would get x squared plus 3x plus 2. So to write them in the actual process, the steps you take is you're going to write both polynomials in descending order. What that means is that you would write x to the fourth plus x to the third plus x to the second plus x plus 1. You would not write like x to the fourth, then x squared, then x cubed. They have to go in order from biggest exponent to smallest exponent. So the second thing is you fill in any missing terms using a 0 for the coefficient. So what that means is that if I had x to the fourth plus x squared, I would have to rewrite that as x to the fourth plus 0x cubed plus x squared plus 0x plus 0. I have to put in zeros for all those missing pieces. Then you're going to put the entire dividend polynomial under the division bracket. You're going to put the entire divisor polynomial outside or in front of the bracket to the left and divide the polynomials, and you're going to stop when you get a remainder of 0 or cannot divide anymore. Now, again, you do not actually have to do polynomial long division. We're going to be doing what we call synthetic division, so skip to the next page. So the whole concept of synthetic division is that synthetic division just focuses on the coefficients. So you're going to start off the same way. You're going to write both polynomials in descending order. And you're going to fill in any missing terms using 0 for the coefficient. And then you're going to put the coefficients of the dividend polynomial inside the division bracket. And you're going to put the negative, which means the opposite of the constant term of the divisor factor outside the bracket to the left. So kind of putting all of this into words. So what they have given us here is this example at the bottom is the polynomial x squared minus 2x plus 5 divided by x plus 4. So this third step said to put the coefficients of the dividend polynomial inside the bracket. Well, my coefficients were 1, negative 2, and 5, and that's where the 1, the negative 2, and the 5 came from down here at the bottom. Then for the next step, it says to put the opposite, or the negative, of the constant term. The constant term is the number by itself, which in this case is positive 4, and I need to put the opposite of that, which is why it becomes negative 4. So now that we have this all set up, we're going to talk about what we're going to do. So we're going to drop the leading coefficient, which would be the first coefficient down. So that's where this 1 comes from. And then we're going to multiply the bottom number by the divisor. So we're going to multiply 1 times negative 4, which gives us negative 4, and that's where that comes in. And then we're going to add vertically to get the next bottom number. So negative 2 plus negative 4 is going to be negative 6. And then I start the process over. I'm going to do negative 4 times negative 6, which gives me positive 24. And then 5 plus 24 is going to give me 29. The last bottom number is the remainder, and if it's 0, you have no remainder. So labeling all these different pieces, what's underneath the radical right here, underneath the division sign, are the coefficients of the dividend polynomial, written in descending order. What's out here is the negative, or the opposite, of the constant term of the divisor factor. What you get here, the 29, is the remainder. And then the minus 6 is going to be the constant term of the quotient. And the 1 is going to be the coefficient of the x term of the quotient. So how this answer works down here says that if I were to divide 1x squared minus 2x plus 5 divided by x plus 4, I would get an answer of 1x minus 6 with a remainder of 29. That is how this answer down here at the bottom translates into an answer for the actual problem. So we're going to move on to the checkup to actually show like how this really works. Problem number 1. I've already gotten it set up in synthetic division for me. And it says 2, and I'm dividing that into 1, 2, and negative 8. So the way this is going to work is I start off and I bring down my 1. And then I multiply. 2 times 1 is 2, and I add. 2 plus 2 is 4. Then I multiply. 2 times 4 is 8. Negative 8 plus 8 is 0. So what this means is that my original polynomial came from these numbers here. And the easiest thing to do is you start with no x, x, then x squared. The next one would have x cubed. So this means that 1x squared plus 2x minus 8 was divided by x minus 2, and that minus 2 came from here. It's always the opposite. And when I divided it, it equaled, and this part down here gives us our answer. And the same process is true. This is my remainder. The next term gets nothing. The next term gets x. The next term would get x squared. So it would be 1x plus 4. That's what I'm doing with synthetic division. So moving on to 3. I'm going to bring down my 2 and multiply. Negative 5 times 2 is negative 10. 11 plus negative 10 is 1. Negative 5 times 1 is negative 5, and 5 plus negative 5 is 0. So what this means is that the function 2x squared plus 11x plus 5, and that came from here. I start with no variables, then I add x, then I add x squared, is divided by x plus 5. The plus 5 came from here because it's always the opposite, equals this part, and that's our answer. Remember, this is the remainder. Then I start off, I add no x's, then I add x, then I would add x squared if there was more. So I get 2x plus 1. Number 5. This one's a little bit longer, but it's the same process. I'm going to bring down my 3, and then multiply. Negative 2 times 3 is negative 6. 10 minus 6 is 4. Negative 2 times 4 is 8. Negative 8. 10 minus 8 is 2. Negative 2 times 2 is negative 4. And 4 minus 4 is 0. So this translates into 3. Okay, let's go back and add our x's in. There would be no x's, x, x squared, and x cubed. So it'd be 3x cubed plus 10x squared plus 10x plus 4 divided by, this gives us our next part, and it's the opposite, so it'll be x plus 2 equals, and the last part comes from this. So remember, this is our remainder. then we add nothing, then x, then we add x squared. So it would equal 3x squared plus 4x plus 2. And that would be our final answer. So moving on to number 7, we have x squared plus 13x plus 36 divided by x plus 9. So this time we actually have to set it up in synthetic division form. So when we put it in synthetic division, we look for our coefficients. Our coefficients are 1, 13, and 36. And then what goes outside comes from the bottom, this part, but it's always the opposite, so it'll be negative 9. And then I start my work. I bring down my 1, and I multiply. Negative 9 times 1 is negative 9. 13 minus 9 is 4. Then I multiply. Negative 9 times 4, which is negative 36. And 36 minus 36 is 0. So this means that when I divide this, my remainder is 0. Then this gets nothing. The next term gets x. So when I divide, my answer is x plus 4. And lastly, problem number 9. So again, I have to set up in synthetic division. So my inside comes from my coefficients. So I have 2, 10, 9, and negative 9. And the outside comes from this number in the denominator, and it's always the opposite, so it'll be minus 3. So I'm going to bring down my 2. Negative 3 times 2 is negative 6. 10 minus 6 would be 4. Negative 3 times 4 is negative 12. 9 minus 12 is negative 3. Negative 3 times negative 3 is positive 9. Negative 9 plus 9 is 0. So this says that when I divided 2x cubed plus 10x squared plus 9x plus minus 9 by x plus 3, I got an answer of 2x squared plus 4x minus 3. And that came from this bottom part down here. Remember, this is our remainder. Then we start with this term and we add nothing. This term we add x, and this term we add x squared. If there was another term, we would add x cubed.